Level of detail, or LOD calculations, can seem confusing, but I'm going to break them down so simply that you'll see your data in a whole new way. I'll show some examples in Tableau, but first I'm going to demonstrate how LODs work. Imagine your Tableau chart is like a camera lens. By default, Tableau focuses on what's in the frame. But with LOD calculations, you can zoom in to see fine details, and you can zoom out to see the bigger picture, regardless of what's in the frame. This flexibility is what makes LOD so powerful. They give you answers at the exact level of detail you need without altering your chart's view. To demonstrate this, I'll start off with a view that has blue bars to represent the sum of sales by region, and yellow bars that use an LOD to show the total sales by region. Say you filter for a category like technology. Tableau recalculates the totals, and the sales number drops because it's only showing what's visible in the view. But with the LOD, it's like zooming out to see the full picture. The calculation locks in the total sales and ignores the filter completely. LODs let you control the level of detail in your calculation, no matter what's in your view. This example that locks in the total uses a fixed LOD. But there are three types of LODs. Fixed ignores the chart's dimensions and filters and calculates at a level you define. Include adds extra details to the calculation while still respecting the chart structure. And exclude removes details from the calculation even if it's present in the chart. Before we jump into building the LODs in Tableau, we need to understand the structure. And it's not hard because they all have the same basic structure. You'll start and end every LOD with curly braces. This tells Tableau that we're using an LOD. Then the type will tell the calculation how to behave. You can use fixed, include, or exclude. The dimension is the field or fields that we're using to define the level of detail. This is where you'll add the field that you want to fix, add, or remove. Then add a colon to separate the dimensions from the calculation logic. The aggregate function specifies the math or logic, like sum or count. And this will determine how the data is combined. While the field defines what you want to calculate, like sales. Now I'll show how to apply these using examples in Tableau with the sample Superstore dataset. I'm starting off with a view that shows sales by subcategory, and I want to know the total sales for each category. So even though the chart is at the subcategory level, I want to compute the sum of sales at the category level of detail. And we can do this using an LOD. So I'm going to create a calculated field for the category sales. I'll start with the curly brace and the type of LOD, which is fixed. And since I want category level sales, I'll type the category field. Then a colon to separate the dimensions from the calculation logic. And to get the total sales, I'll type the sum of sales. I'll end it with a curly brace and hit OK. Now I can bring the category sales field into the mark and the category as well. And you can see the tooltip not only includes subcategory sales, but also the total sales for the category it belongs to. This gives us the big picture, which is category totals, while still keeping the details, subcategory sales, within the chart. And you can see the total sales for the category office supplies is about 700,000. What I mean by this calculation is independent of what's in the chart, is that I can filter the chart to exclude one of the subcategories within office supplies, like appliances. And the total sales for the office supplies category doesn't change within the chart. This is because the fixed LOD overrides filters and only calculates based on the conditions we define, whereas include and exclude respect the filters in the chart, which I'll show later. So this is an example where I created an LOD using a fixed condition with only one dimension, but I'll also show an example using multiple dimensions. I'll right-click on category sales to edit it, and this will be for category sales that also takes into account the region. To add a dimension to this LOD, I'll type a comma after category, and then add the region field. Now the calculation is grouping by category and region, and it's saying ignore what's in the chart and give me the total sales for each category region combination. So when I pull region into the view, you can see that art, which is in the office supplies category in the central region, has the same value as binders, whereas accessories is in the technology category, so its central sales total is different. Even though this chart has a subcategory level of detail, our calculation uses the region and category level of detail. The fixed LOD is the one that I use the most because it lets you calculate at any level no matter what's in your chart. And while fixed lets us ignore dimensions in the chart, include respects the dimensions and filters in the chart and lets us add a dimension to the calculation. For the include example, I'll start with a view that has sales by category, and I want to know the average sales per product within each category. Basically, I want to add the product detail or dimension to the calculation without changing the chart. So I'll create a calculated field for the average sales per product. I'll start with the same structure by adding a curly brace, and this time I want to type include. For the dimension, I'll use product name, type a colon, and I want the average sales. Then I'll end it with a curly brace. When I pull this field into the view, you can see the calculation is forcing Tableau to include product, even though the chart only shows category. It gives us the bigger picture, which is the category level totals, with details like the product level averages in the same view. I'll show the back end of the LOD on this table to explain how it's calculating. This table just has the sum of sales for each product, and I filtered it by the category furniture. When I pull in our new calculated field, you can see we get different numbers for each product, which is also going to make the totals different. To make these easier to compare, I'll change both of the aggregations to the average. And now you can see for each product we get the same number, but the grand totals are different. The difference is that the average of sales calculates the average across all the rows, versus our LOD calculates the average sales for each product first, then averages those product level averages. So when I add order ID to the view, it's now displaying data at a row level, as in one row per transaction. And this causes our LOD to behave the same way the average of sales calculation does. I'll change these back to sum, and to show how a filter affects include, I'll add product to the filters and exclude one of the products within our furniture category. So unlike the fixed type that ignores filters, we can see include respected the filter that we added, and that caused the grand total to drop. While include adds dimensions for more detail, exclude removes dimensions to focus on broader trends. For the exclude LOD example, I'm starting with a view that has sales by category and region, and I want the total sales for each category without considering regions. Basically, I want to remove the region detail from the calculation, even though the chart includes it. So I'll create a calculated field for the category sales, ignoring region. I'll start with the same structure with a curly brace, and then the LOD type exclude. I'll type the dimension I'm ignoring, which is region, and a colon. And the math will be for the sum of sales, and I'll end it with a curly brace. I'll add this to the view, and you can see that instead of calculating sales broken down by category and region, which is the default behavior in this chart, the LOD calculates the total sales at the category level only, completely ignoring region. And that's why all the region bars within one category show the same value. I'll show you how we can achieve the same result by using a fixed LOD. I'll bring the category sales LOD that we created at the beginning into the marks. And while our fixed and exclude LOD show the same value, they behave differently. I'll show this by bringing region into the filter and removing one of the regions. You can see the exclude LOD adjusts for the filter and ignores the region we removed in the calculation, whereas the fixed LOD ignores filters. So it has the same value no matter what region we filter for. This last example combines LODs to demonstrate their true power, and it points out a common error in how to fix it. Like the first example, I'm starting with sales by subcategory, and I want to know the category percent of total sales. So I want two distinct levels of aggregation. We already have the total sales at the subcategory level, so I'm going to quickly create the view of percent of total sales at the category level. And these are the values we're going to calculate within the LOD. I'll go back to our sales by subcategory view and create a calculated field for the category % of total sales. I'll start by getting the total sales for each category, which is holding fixed the category, take the sum of sales, just like we did in the first example. Then I need to divide this by the total sales across all categories. But if I just type the sum of sales, you can see we get this error that you can't mix aggregate and non-aggregate arguments. So to fix this, we can turn the sum of sales into an LOD. Since I'm not including any dimensions in the LOD, it's saying ignore all the dimensions in the view and calculate the total sum of sales across the entire dataset. Now I'll bring our new calculated field into the view and the category as well. Now we can see the % of sales for each category. For example, since appliances and binders are both in the office supplies category, they have the same value for the category % of total sales. An LOD was necessary to get these values because the view is currently at the subcategory level of detail. If we try to replicate these values by dragging sales in and applying a quick table calculation for the % of total sales, it would instead calculate the subcategory % of total sales, not the category level %. That's why different subcategories like binders and appliances have different values for this measure. To recap, level of detail or LOD calculations lets you calculate at a different level than what's shown in your chart. The three types include fixed, which locks the calculation at a specific level. Include, which adds more details to your calculation. And exclude, which removes details to focus on a broader level. LODs let us answer questions that regular calculations can't, like comparing different levels of detail within the same view.